The notes today are on reflections. This is another kind of transformation. Yesterday we did translation. Today reflections. All right, so now reflections are a transformation where a figure is viewed over a line of reflection. And our line of reflection in this case is going to be an x or a y axis usually when we're dealing with the coordinate grid. So you're going to be reflecting, like a mirror, something over the x or y axis. Now, a figure that where the halves match exactly when it's folded is said to have a line of symmetry. Okay, so these figures that you see on the screen right here have lines of symmetry. This one has 1, 2, 3, 4 lines of symmetry. We could take this and draw this figure on a piece of paper and fold it 4 different ways and have all of the edges match up exactly. So those are lines of symmetry. This figure here only has 1 line of symmetry going through the middle. If we fold this down, it would match exactly. The corners would match exactly. We could not cut it through the middle this way because when you folded this corner over here, it would end up somewhere along the outer edge over there. So it only has 1 line of symmetry horizontally through the middle. All right, now figures can be reflected over either the x or the y axis. Now when you reflect a figure over the x-axis, it changes the sign of the y-coordinate. So in other words, if we have an ordered pair, such as 1, 3, if we reflected that pair over the x-axis, it changes the y-coordinate to a negative. So we would have 1, -3. Same way if we started with 1, -3, then the 3 would become positive over here. So the y-coordinate changes signs when we flip over the x-axis. If we want to flip over the y-axis, our x-coordinate will change signs. So we have 1, 3, and to flip it over the y-axis, our x-coordinate changes. So then we would have -1, 3. The y stays the same, the x changes. So the way to remember this is reflection your axis coordinate stays the same. Okay, so if I'm flipping over the y-axis, my y-coordinate stays the same. If I'm flipping over the x-axis, my x-coordinate stays the same. And then the other coordinates change signs. Okay, there are more lines of reflections besides just the x and y axis, which you'll talk about in future math courses, but for this year we're just talking about the x and the y axis reflections. Okay, so reflecting a figure over the x axis. Here we have triangle ABC. This is the original triangle because down here we have A prime, B prime, C prime. All right, now these two figures look as if you took a mirror and put it right along that x-axis. Okay, so here's the x-axis. It looks like there's a mirror in between these two figures. So our axis of reflection is the x-axis here. Okay, now when we look at triangle ABC, we see that A is at 5, 2, B is at 1, 3, and C is at -1, 1. We're just going to fill those in over here. 5, 2, 1, 3, and -1, 1. Okay, those are given to us already. Now, if we are going to flip this image over the x-axis, remember the axis that we're flipping over, that coordinate stays the same. So if we're flipping over the x-axis, we're going to keep all of our x-coordinates. 5, 1, -1. And then what we do is change the sign of our y-coordinate. So if our y-coordinate starts out positive, it's going to become negative. If it starts out negative, it'll change to positive. Okay, so we can do -2, -3, -1 here. And then we would go ahead and graph our new triangle, and it should look like it's reflected over the x-axis. We're going to look at 5, -2. So here's the 0 line, 0 point of origin. 1, 2, 3, 4, 5, negative 2. That's correct. 1, negative 3. So positive 1, negative 3. B is in the correct location. And negative 1, negative 1. C is in the correct location. Okay, so notice how the y coordinates have become negative, but the x coordinates stayed the same when we reflect over the x-axis. Let's look at this one. All right, so here we have a quadrilateral. The quadrilateral is KLMN. It tells us that our vertices are at 2, 3, 5, 1, 4, negative 2, and 1, negative 1. Okay, that's where we're starting. That's going to be the blue figure over here. And then the green figure over here has the prime letters. So that's our new quadrilateral. So you can see that we're flipping over the x-axis this time. Or I'm sorry, the y-axis. We're flipping over the y-axis this time. So our mirror is going right here. This would be our mirror that's reflecting the two sides. So if we're reflecting over the y-axis, now our y coordinates are staying the same. So y-axis, I'm going to copy my y coordinates. 3, 1, negative 2, negative 1. Now all of my x coordinates will change their sign. So we go from positive 2 to negative 2, positive 5 to negative 5, positive 4 to negative 4, positive 1 to negative 1. And if you notice, when you're looking at the y-axis or even the x-axis on the last one, if we just go up here to k is 1, 2 coordinates away from y. It's 2 units away from y on the right side. Its reflection is 2 units away on the left side. Okay? Letter N down here is 1 unit away from the y-axis on the right side, and its reflection is 1 unit away on the left side. We can do that for any of these letters. We can just count how many units away from the axis it is and reflect it over the exact same number of units on the other side. Now sometimes these figures will come over the top of the y-axis, and then it gets confusing. So that's why it's good to know how to figure out what your coordinates are going to be before you draw the figure. Okay, so determine whether these figures have lines of symmetry, and if so, how many. So we're looking at this one right here, letter H. Now you probably all have figured out that you have at least one line of symmetry going down here. Okay, so if we wrote this H exactly like this on a piece of paper and we folded it in half this way, all of our corners would match up. Now, there's one more line of symmetry for the letter H, and it goes this way. We could also fold it down the middle this way, and all our corners would match up. However, if you take a piece of paper and you fold it diagonally, this letter H, these corners will not match up to each other. So whenever you have a figure that you're not sure what line of symmetry it has, you can draw it on a piece of paper and try and fold it in half. The letter G, does it have a line of symmetry? Well, if I try to fold it this way, I'm not going to get a match. And if I try to fold it this way, this little corner has nothing to match up with up here. Same way, any direction I try, it has no line of symmetry. This figure over here also has no line of symmetry because this little piece right here is slightly different than that, so I can't fold it this way. This side doesn't have any points on it, so I can't fold it in half this way. It also won't work this way or this way. So the only figure here that has a line of symmetry is the letter H, and it has 2 lines of symmetry. You can have more lines of symmetry also. All right, flipping this figure over the x-axis, RST, triangle RST. First, we have to figure out what our original coordinates are. So we've highlighted the axis that we're flipping over, and that's a big help. It's a good strategy to highlight the reflection axis. Okay, so R is at, let's remember how to count now. We start at 0 and we go left and right first. We count left, right first, and then we count up or down. So it's at positive 1. Remember, this is positive, that's negative. This is positive, that's negative. So we're at positive 1, negative 1. 1, negative 1. Our letter S down here, we would go 1, 2, 3, positive 4, and then 1, 2, 3, negative 4. Positive 4, negative 4. And T is at positive 1, and then negative 1, 2, 3, 4. Positive 1, negative 4. If we are flipping over the x-axis, which coordinates stay the same? The x-axis coordinates stay the same. Okay? The x-axis coordinates are going to stay the same, so I'm just going to copy all of these down. 1, 4, 1. And then what happens to the y-axis coordinates? They change their sign. So this was negative 1, it's going to become positive 1. Negative 4 becomes positive 4. Negative 4 becomes positive 4. Now we're going to graph our new triangle. It'll be triangle R prime, S prime, T prime. And R prime is at 1, 1. So that's positive 1, positive 1. So that goes this direction 1 and that direction 1. X and then Y. So here is R prime. S is at positive 4, positive 4. So we're going to go this way and then up. So 1, 2, 3, 4, 1, 2, 3, 4 right here. That is S prime. And then T prime is at positive 1, positive 4. So positive 1, and then 1, 2, 3, positive 4. That's T prime. Okay, and then we're going to draw. You're going to use a straight edge. I wish I had one for my tablet here, but I don't. Okay, so there's our reflected triangle. It looks like it's reflecting across a mirror. Okay, you're going to continue to practice this on the y-axis this time. So you can copy down your original coordinates here. 1, negative 1, 4, negative 4, 1, negative 4. Okay? 1, negative 1, 4, negative 4, 1, negative 4. Now, since we're reflecting over the x-axis this time, notice that, or I'm sorry, the y-axis this time, notice the y-axis is highlighted here. And so the y-axis stays the same. So now I'm going to copy my y-axis numbers here, negative 1, negative 4, negative 4. And I am going to change my x-axis numbers, the sign of them. So it was positive 1, so now it's negative 1. Positive 4 is now negative 4. Positive 1 is negative 1. And now I can go back and graph that reflection. So R is at negative 1, negative 1. So here's my negatives down here, and my positives are up and to the right. Okay, so starting at the origin every single time, I'm going to go negative 1, negative 1. So that means this direction 1 and then down 1. That's R prime. S is at negative 4, negative 4. So negative and negative. 1, 2, 3, 4. 1, 2, 3, 4. There's S prime. And then T prime is at negative 1, negative 4. So negative 1 and then 1, 2, 3, negative 4. T prime. And then you're going to carefully, with a straight edge, draw in your triangle. And there you go. It's like a mirror reflection over the y-axis. The key word for reflection is going to be flip. You should look like you have flipped that figure over in a mirror. I'm going to have you go ahead and complete the reflections assignment on your own, and be sure to use a straight edge because neatness does count.